Hello students, I'm Professor Bodziak. I will be your science teacher in this talk. When I finish the talk, I will ask a question, concerning the talk. Please put your answer to the question in the chat section. And if you view this talk on YouTube, put the answer to the question I ask in the comments section. Okay, I'm going to begin by talking about batteries. So again, we're all very familiar with batteries. They're so prominent in our everyday lives. Here's an example of a battery. Here's another example of a battery you're familiar with. And again, the battery has a positive terminal and a negative terminal. So one end of the battery is the positive part, and it's called the cathode in science. The negative end is called the anode. Okay? So you've got to put this battery in the proper position in a flashlight or a transistor radio in order for the device to work properly. If you were to, for example, turn the battery upside down when you put it in, it would not work properly. So the charged ends of these batteries are very important. Okay? Now, this negative end of the battery, called the anode, it's composed of zinc, most commonly, a very common metal. Cathodes are commonly composed of magnesium dioxide. The heart of the battery, the main substance of the battery, is filled with an electrolyte. We call that material an electrolyte. It causes the battery basically to have the properties of a battery. Okay? Batteries have electrical potential. Okay? So a small 1.5, well, we will discuss the concept of voltage very soon, but a small battery has a very small voltage, 1.5 volts, as opposed to maybe if you had looked into under the hood of an automobile and saw a larger 12-volt battery. Okay? So it has electrical potential. Now in physics, we often talk of the potential an object would have if I would just hold it above the earth. Okay? Because if I let go of the object, it hits the earth or some such surface with some force. Okay? Similar, the battery has the ability to do work electrically, as opposed to the work being done here is I just release an object that I've held above the surface of the earth. Now, batteries are DC, which stands for direct current, as opposed to AC, which stands for alternating current. So the direct current of a battery is a constant value. This battery is constant 1.5 volts, as opposed to the voltages that come from our walls when we plug our devices into the outlets of our walls. That is a varying voltage, an AC alternate. It's called AC. It stands for alternating current. Okay. We'll discuss that shortly as well. For now, let us concentrate on the battery and this material called an electrolyte. The bulk of the battery is made of an electrolyte. Okay, This is often a material called potassium hydroxide. Which is very critical in helping us to produce this electrical potential in a battery. As well, acids can be used in batteries. Sulfuric acid is a very common acid. Car batteries oftentimes use sulfuric acid. So it's also very much true that when working with a car, underneath the hood of a car, people need to be very careful, all right, and things that they do related to the battery. If they would make the battery explode, now that would be sulfuric acid, which would get onto the bodies of a person that would be near this exploding battery. Okay, so that would be something we would have to be very, cautious not to have that happen. Acids eat away at materials that they come in contact with. So that's one thing that would have to be thought of when you deal with car batteries. Now, this material in the center of the battery is called an electrolyte. Okay? The electrolyte causes a buildup of electrons on the cathode. It's doing a chemical combination with magnesium dioxide in the cathode. Now, since the cathode is made of magnesium dioxide, this material in the center, the electrolyte, is chemically combining with it. These electrons are negatively charged. So there's a buildup of electrons in the cathode. Okay? Electrons in large numbers begin to exist, and since they are all of like charge, they repel each other. Okay? In the anode, the electrons of the anode are now attracted to the electrons, to the missing areas where the electrons were in the cathode, because they were taken away chemically by the electrolyte. So now, if you were to connect a device like a light bulb with a wire to the anode and the other end of the wire to the cathode, with the bulb being in series in this circuit. This is now called a circuit. The word circuit comes from the word circle, because we create a circle here in order for electricity to flow through this device. So in the anode, the electrons get attracted to the cathode, and now the electrons are flowing in this wire. Electrons flowing through this wire are powering this device, and in this picture I've drawn a light bulb, so it's powering the bulb. We could put some other device in here, like a radio, for example. The important thing is we must have a complete circuit in order for this to operate as desired. Now, several hundred years ago, during the founding of the United States, we had a very great leader whose name was Benjamin Franklin. He was a great political leader. He was also a great scientist. Okay? Benjamin Franklin is credited with the discovery of electricity. So Mr. Franklin actually flew a kite during a thunderstorm, and on this kite he had a wire which was connected to a key that he had into a jar as he stayed on the ground flying the kite. Now, when the kite was struck by lightning, electricity traveled down through the wire through which Mr. Franklin held the kite, and it caused sparking on the key in the jar. Mr. Franklin concluded that the particles causing this charging were positively charged. He was incorrect in his conclusion. Okay, he did discover the electricity, but his conclusion of being positively charged was not correct. These electrons are negatively charged. So, when we draw a picture of a circuit, the electricity was initially considered to be moving from the positive end to the negative end of the circuit. And even today, we still use that concept, because if we change that idea, it would alter too many things in the way that diagrams of such circuits were drawn in the past, the work previously done. And so we still draw diagrams showing the direction of the electric movement, which we call electric current, to go from the positive end of in this case, a battery. It could be an electrical device called a power supply as well. So the battery is a form of a power supply. Okay. We still draw it, current going from the positive end to the negative end of the battery as it travels through a electrically powered device. So here's a diagram of such a picture. Here's a 12-volt battery. Here's a circuit. I stands for current. Okay, so current is moving electrons. This little device is called a resistor, which we will go into more detail. Okay, so we have current flowing from the positive end through the resistor, ending in the negative end of the battery. Okay, so this little device I've drawn with these zigzag lines is a resistor, and it's called that. It's an electrical component called that because it resists the flow of electricity. So resistors resist the flow of electricity. The wire that we use, which would be most often made of copper, as your common pennies are made of, would be the conductor in this. And again, as I had mentioned, we call this a circuit, and it comes from the word circle, because if there was a break anywhere in this circle, then the electrons would not be able to flow, and whatever device we put into this circuit, it would not be able to function properly. A light bulb wouldn't turn on. Okay, we would have what is called an open circuit, because somewhere in this circuit there would be a break. Okay, so once again, this I signifies a positive charge flowing from the positive end of the power supply to the negative end. This does not actually work in this manner, because what's really happening is electrons are flowing from the negative end to the positive end. However, in effect, it's the same. It ends up being the same. The end result is the same, because it's negative charges that are moving in the opposite direction. Okay, so negative going from the negative to the positive end has the same result as if there were positive particles, as Mr. Franklin believed, going from the positive end to the negative end. So in actual use, that error Benjamin Franklin made is not critical, since movement in the opposite direction of an opposite charge basically has the same result. Now, one critical point we have to keep in mind concerning electricity is that power outlets in our homes have electrical potential. And now the value of this potential is commonly 120 volts in the United States. Actually, many countries in Europe use a much higher voltage in their homes. 240 volts is a pretty common voltage used in many European countries. Now, many of us are familiar with the fact that electricity can make something very, very hot, right? For example, our electrical heaters, right? If you ever turned on an electrical heater in the wintertime, right? So the electricity flowing through the conductors and the heater is generating heat, which is then blown out towards us with a fan. Okay, so electricity and heat are very closely associated, which could be very, very dangerous if it was a very, very high voltage. For example, the voltage on if you look outside and you look at your telephone lines and you see wires up on the telephone lines, usually it's the 4,000 volt range of voltage up on those lines. Okay, and we will discuss how that becomes 120 volts, which comes out of the walls in our homes, which we then plug in our electrical devices to run, for example, our electrical heater or our refrigerator or our computers. Okay, so the 120 volts that comes out of our wall is really not enough to cause a whole lot of immediate damage in burning something, all right, even if that something would be a human being. However, it is still a very, very dangerous voltage, and in fact it's called the death voltage because of the physiology of a human heart. Okay, 120 volts just happens to be a prime voltage that would cause the heart to fibrillate. This word fibrillate is related to the concept of heart action in biology. So this ties in the biological sciences with the science we've been discussing. So the heart has valves which open and close in order to let blood flow into the heart, and the proper valves then close, and the proper valves then open as the heart pumps blood out of the heart. The blood is now pumped out of the heart into the rest of the body. Under 120 volts, the action of these heart valves can change and they become abnormal. And this is very dangerous because now the blood is not flowing through a person's body the way it's supposed to. The heart is not functioning the way it's supposed to, and the blood is not circulating and giving oxygen to the parts of the body of the person involved, which is why being associated with this voltage coming out of the wall in our homes, or any of the businesses we may go to. We go to a grocery store or a business, or our schools for that matter, right? This voltage, if misused, can be very, very dangerous. We must be very cautious in this, okay, when we work around such things. Okay, so we discussed the existence of electrons. They're particles of negative charge which orbit the nucleus of an atom. So I will now give a very important definition, a coulomb. Now we are coming soon to the close of our talk, so let us review some of the things we've been discussing. We were discussing today the concept of batteries and how we use these batteries in many of our electrical devices at home. We power flashlights, transistor radios, maybe some of the toys that we play with. Okay, so the battery has a positive end which must be inserted properly into the device we're trying to power, and a negative end. The positive end is called the cathode. The negative end is called the anode. The cathode is often made of magnesium dioxide, and the anode is often made of zinc. Okay, so we have the center of the battery filled with what is called an electrolyte. So it's actually a chemical reaction, which you will learn later in your life in high school chemistry. So with a battery, we're discussing DC voltages. So again, voltage is a form of electrical potential. See, the battery has potential, just like an object sitting above the earth has potential. We could drop it and it hits the surface of the earth with force. Okay, so we discussed how the symbol for a resistor is this squiggly line, and a resistor basically resists the flow of electricity. Okay? So electricity is moving electrons, and the atoms that make up the conductor, which would be the copper wires that make our circuit, they do not hold on very tightly to their electrons. So basically the electrons coming out of the battery bump into each other. They bump into the electrons that are composing the copper wires. Okay, and these atoms composing the wires give up their electrons as more electrons move in. Okay, so electrons bumping into each other basically is what the flow of electricity is. We gave a definition of what a coulomb is. A coulomb is 6.25 times 10 to the 18th electrons. So we can write that number out in full. 6.25 times 10 with 18 zeros behind it. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. Okay? Think of that many, 6.25 times that many electrons. All right? Which is a great deal of electrons, just seeing that number. Okay? We also discussed how the electricity that comes out of the wall of our homes, or if we go to a store or our schools even, or any type of a business, it's using 120 volts in the United States, common voltage. Be very, very careful when we deal with the electricity coming from our walls, coming from the outlets in our homes. Okay, and as we discussed earlier on in the lecture, I'd like you to answer a question. What is the positive end of a battery called? What is the negative end of a battery called? Please answer that in the chat section, or if you watch this clip in the YouTube, okay, you can put your answer in the comment section. And once again, what is the positive end called? What is the negative end called? All right, thank you.